Hi, my name's Rachel May. This is my video for Physics 106. I'm going to be talking about image formation by the eye. And to talk about that, I'm first going to describe some of the anatomical features of the eye. So I'm going to draw one out right here. So first we have just kind of the body of the eye. If you're curious, it's called the sclera. And over that, you kind of have this bulging out part that is called the cornea. This is one of the first parts of the eye that the light hits, and it is essential to vision formation. After that, we have this little guy that comes out. This is going to be your iris. So this is what makes your eyes blue, or in this case purple, I guess. Then after that, we have probably one of the most important parts that we've all been waiting for. Oh, it's the wrong color. Which is the lens. It sits right behind the iris, right where the pupil is. And attached to the lens are going to be these little strings called the ciliary zonules. That'll make a little more sense later. Attached to this muscle called the ciliary bodies. And right here we have the lens. Lastly, we have the retina, which sits on the back of the eye. Whoops. This is for retina. This is 3, for ciliary body and for the lens. Okay. So first I'm going to quickly talk about the cornea and eventually the iris. They kind of go together. So you can see the cornea, it's bent out, so it kind of acts like a convex lens. So when light comes in, I'm going to find my yellow marker right here. So when light comes in, it's going to hit the cornea, and the main job of the cornea is to refract light in so that it can reach the lens. Our iris is kind of like a camera shutter. I don't know that much about cameras, but I'm going to call this a camera shutter, where it controls how much light we're letting in. So you can see here when your pupil is dilated, when the iris is kind of pulled back, lots of light can be let in. However, when your pupil is really small, not very much light can get in. Like if I made it to here, the light coming from whatever image this is would not be able to get into the eye. So that's the purpose of the iris. Then next we're going to talk about the lens and all of this fun ciliary stuff. So again, I'm going to talk mostly anatomically. So the lens is really what lets us change our focus. So the cornea is bringing light into the lens, and then the lens is going to change focus. We can either have like far-sighted, we're looking into the distance, or we can have nearsighted, we're trying to look close to us. And how we change between these two is something called accommodation. And this involves these muscles, the ciliary bodies. So when our eyes are relaxed, they are in a naturally far-sighted situation. When you're far-sighted, the lens is pulled thin, and here we have those ciliary bodies, those muscles, they're flat and they're relaxed. So the strings that pull on the lens are very tight, which is why the lens is spread. However, when you're nearsighted, those muscles are now not flat, but they're thick, and they're shorter. And this shortness causes those strings to be very loose. And because they're loose, the lens naturally wants to get fatter. So this is a little bit more of the physics behind the lens. So here I have both the fat lens and the thin lens. So this would be like nearsighted, this would be looking far out into the distance. And I'm going to kind of do my best to explain. So this, if you remember from class, is like a case 1, where we have our distance of the object is going to be greater than our focal length, and focal length is positive. So knowing that distance of the object is greater than the focal length, actually scratch that, never mind, I'm going to talk about this first. So the distance of the image inside the eye, here's the retina, here's like the object, lens, retina. The distance inside the eye cannot change. You can't just make your eye like skinny and then you can't make your eye fat. But you can make your lens thin and you can make your lens fat. So this, again, distance image is constant and it's usually about 1.8 centimeters. So instead of changing the distance of the image, what the eye will do is it'll change the focal length. And how it changes the focal length is by changing the thickness and the thinness of the lens. So if we go up over here to this equation, it's a little small, sorry. We have 1 over distance of the object plus 1 over distance of the image equals our focal length. So if this is a constant number, and we can just change whatever distance we want, like maybe 1 meter, then you would get that the focal length of the eye would need to be 1.77 centimeters. So that means that if this distance needs to be 1.77 centimeters, the lens can either fatten to make the distance shorter, or you can see here it can get thinner and make the focal distance longer. So that is kind of a little bit of the physics. And if you want to think of it another way, over here we have the power of the lens. Power of lenses is defined as 1 divided by the focal length. And you can see here that the shorter the focal length, or the smaller the focal length, the bigger the power is going to be. And larger power means you can see things closer up. So the longer the focal length, the smaller the power will be, which means you can't see things as close up, but you can see things that are very far away. The last way I kind of like to think about it is just this relationship right here, that the distance of the object is always greater than the focal point. So if we have a longer focal point created by this thin lens, that means we're going to be able to see objects farther away. If we have a smaller focal point, then this DO is going to be smaller. Not smaller than the F, but it will be proportionally smaller. And it will be proportionally smaller according to this equation up here we learned in class. So that is kind of a very basic explanation of the physics behind vision with the lens.